Alright class, in this video we continue our discussion of section 4.4, laws of logarithms. We are starting at the top of page 4 of your lecture handout. We're going to work a few more examples of expanding a logarithmic expression. And so just to remind you, when you expand a logarithmic expression, we're starting with a single logarithm like this one at the top of page 4, and then applying the three laws of logarithms, we're going to write it as a sum and difference of logs like down here at the bottom. So we're given the common log of y to the 7th over the square root of 3x. So the first thing we want to do is break up this quotient, applying the quotient rule. Quotient rule says this is equal to the log of the numerator minus the log of the denominator. So we have log of y to the 7th minus the log of square root of 3x. Well, whenever you take the square root of something, right, that's the same as raising it to the 1/2 power, right, as a rational exponent. So we replace square root of 3x with 3x to the 1/2. The common log of y to the 7th, this 7 can be brought out in front of the log by the power rule, and so this first term is equal to 7 times the log of y, and then we have minus the second term. Now by the power rule, this exponent 1/2 can be brought out in front of the log, and we have minus 1/2 times the log of 3x. Well, now 3x is a product, right? 3 times x. So by the product rule, the log of 3x can be written as the log of 3 plus the log of x. And then we distribute the minus 1/2 inside the parentheses, and we end up with 7 log y minus 1/2 log 3 minus 1/2 log x. And so this single logarithm up here, right, it can, when fully expanded, equals this down here at the very bottom. Next we have the common log of x to the 7th times y to the 8th all over z cubed. And so again, we will apply the quotient rule to break up this quotient. So this is equal to the log of the numerator minus the log of the denominator. So we have log of x to the 7th times y to the 8th minus the log of z cubed. Well, x to the 7th times y to the 8th is a product, so we apply the product rule, splitting that up, and we have log of x to the 7th plus the log of y to the 8th. At the same time, in the second term, 3 is an exponent on the variable z, so we can bring the 3 down in front of the log, and we have minus 3 times the log of z. Now, 7 is an exponent of variable x, so it can be brought down in front of the log here. 8 is an exponent of variable y, it can be brought down in front of the log here, and we end up with 7 times the log of x plus 8 times the log of y minus 3 times the log of z. This is our final answer, right? This logarithm up here, right, when fully expanded, equals this down here. Then lastly, we have the log base a of x to the 5th over y times z to the 6th. So a is some base, right? Remember, the base a has to be a positive number, not equal to 1. So again, we're taking the log of a quotient. So the first thing we want to do is split up that quotient. So this is equal to log of the numerator minus the log of the denominator. Well, so we have log base a of x to the 5th minus log base a of y times z to the 6th. So this first term, right, 5 is an exponent of the variable x. The 5 can be brought down in front of the log, and we have 5 times log base a of x. And then we have the log of y times z to the 6th. So by the product rule, that's equal to log base a of y plus log base a of z to the 6th. Okay, and that has to, when you expand this using the product rule, right, it has to be put in parentheses because we're subtracting this log, and this log is equal to this sum. So you got to put the sum of these two logs inside the parentheses. And then lastly, the 6 on the variable z here can be brought down in front of the log. So we have 6 times log base a of z. And then when we distribute the minus sign inside the parentheses, we have minus log base a of y minus 6 times log base a of z. So this logarithm, the single logarithm up here, when fully expanded, equals this quantity, this down here.